Now every object in the universe attracts every other object with a definite force, and this force is directly proportional to the product of the masses of the two objects and the square of the distance between them, inversely proportional to the square of the distance between them. If supposing if the mass of this object is m1 and the mass of this object is m2 and the distance between them is d, then F is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. If I remove the proportional sign and put equal to sign, I'll get a constant G m1 m2 upon d square. What is d? Known as universal gravitational constant. Now how to find out the unit of universal gravitational constant G? Now bring m1 m2 and d square on this side, on left hand side. What you'll get? G is equal to F into d square upon m1 into m2. Now what is the unit of force? Force is what? Newton. And what is the unit of d? D is what? Meter. Since it is square, we will put a square. What is the unit of mass? Mass is kilogram, and this mass is also kilogram. So what is the unit of gravitational constant? G, Newton meter square per kg square. So the unit of G is what? Newton meter square per kg square. It can also be written as Newton meter square. Instead of writing per, you can directly write kg, but to the power of minus 2. To the power of minus 2. Now Henry Cavendish was the scientist who found out the value of G. So Henry Cavendish found out the value of G, which was equal to how much? 6.673 into 10 to the power of minus 11 Newton meter square per kg square. Now if the masses of the one object is double, if the mass of one of the object is double, then the force will also be double. But if the distance is double, then the force will decrease by a factor of 4. Why it will decrease? Because it is inversely proportional to the square of the distance between them. If the two bodies are spherical or not spherical, if they are spherical or they are not spherical or have an irregular shape, then the direction of the force, is always along the line joining the centers of the two bodies, and the distance between the center is taken to be d. The center of an object, the center of this object is the point, either it will be inside or outside depending upon the object at which the total mass of the object can be assumed to be concentrated. The center of the mass of spherical object, supposing if it's a spherical object, then the center will be the geometric center. It is also known as centroid. The center of a mass of spherical object having uniform density is at its geometrical center. It is also known as the centroid. Now we had studied that the center of a mass of an object is a point inside or outside the object at which the total mass of the object can be assumed to be concentrated. Now what is the meaning of this? Now if I take a circular disc means what? Fully it is covered with some matter, then the center of the mass, the center of that object will be, of the circular disc will be exactly at the geometric center. Now if I take a wire, a thin wire, then where will be the geometric center? Exactly at the middle of the wire. Now if I take the same wire and change the shape into, instead of keeping it straight, I can change it into a circle. So if I change it into a circle, then where will be the geometric center? It will be exactly at the center of this ring. Now this is a hollow. Hollow means what? There is nothing inside. The wire is outside. So the center is outside the object. Here the center was on the object or inside the object. But the same wire, when I change the shape of the wire into a circular ring, when I change it into a circular ring, like for example the bangle is circular ring like. So where is the exact center of it? It is outside. It is not on the wire, it is outside the mass of the object. So that is the meaning, the center of the mass of an object can be inside or it can be outside the object, where the mass is assumed to be concentrated. For a scalene triangle, it will be at where all the medians meet, that will be the center. And in case of solid cone, it will be h upon 4. Supposing the height is 12 centimeter, then 12 upon 4 is 3 centimeters. So this distance will be how much? 3 centimeter. When I divide 12 by 4, I get 3 centimeters. So it will be 3 centimeter above the base. If it is a hollow cone, then it will be where? H upon 3. If same thing, if the height is 12 centimeter, then where it will be? When you divide 12 by 3, then this distance will be equal to 4 centimeter. That is 12 divided by 3 will be 4 centimeter. Now this is a solid cone, that means fully it is filled with a matter. So the center is inside the mass of the object. But in case of a hollow cone, like the cone which you use on the birthday party, which you please place it on the head, on birthday party cones are available, so that is hollow. In that case, the center is outside the mass of the object because it is hollow. So whenever it is hollow, the mass is outside. Whenever it is a solid, then the mass is inside the object. So that is the meaning of this. Now supposing an object of mass m is moving around in a circular motion with constant speed, and the radius of the circle is r, then the force is equal to what? mv square upon r. Similarly, in place of the object, if planet is there, if a planet is revolving around the sun in a circular orbit, then centripetal force will be equal to how much? F is equal to mv square upon r, where m is what? Mass of the planet. V is what? Speed of the planet. And R is the radius or the distance between the planet and the sun. Now distance traveled by a planet, since a planet is moving in a circular motion, so circular motion is equal to what? Perimeter, and perimeter is always equal to how much? 2 pi r. So in a circular motion, distance is equal to perimeter, and perimeter is equal to 2 pi r. Then V is equal to what? Distance upon time taken. That's equal to, distance is equal to how much? 2 pi r. And time taken is equal to what? Period of revolution, that is t. Now put this value of V in this equation. So what you will get? F is equal to m. Instead of V, you will put 2 pi r upon t the whole square upon r. Now when you open the bracket, what you get? M 2 the whole square will become 4 into pi r square into r square upon t square. This t square you can bring it in the denominator, so it will become t square into r. Now one of the r will get cancelled, so what will be left over here? 4m pi square r upon t square. Now multiply the denominator and the numerator and the denominator by r square. So multiply by r square and divide by r square. So what you will get? F is equal to 4m pi square r cube upon r square into t square. Now we had already studied Kepler's third law, that t square upon r cube is equal to constant k. Now if I reverse it, what I'll get? R cube upon t square is equal to, this is k upon 1, so it will become 1 upon k. So in place of r cube upon t square, you will write what? 1 upon k. So F is equal to what? 4m pi square upon r square, 4m pi square upon r square into k. k is also there, so r cube upon t square will become what? 1 upon k, so k will come in the denominator. Now over here 4m mass of the planet pi square upon k is equal to constant. The value of pi is constant, 4 is constant, mass of the planet is also constant, and k is also constant. So this full thing is constant. So it depends upon what? R square. So Newton concluded the centripetal force always is inversely proportional to the square of the distance between the planet and the sun. That is how he was able to prove the Kepler's third law mathematically. Now page number 6, use your brain power. There is one sum which we have to solve it. They have said assuming the acceleration in example 2. So in example 2 they have already found out the value of acceleration. You have to take the same value. So a is equal to 5.34 into 10 to the power of minus 9 meter per second square. And the distance between Mahendra and Virat is how much? 1 centimeter. So let us take S is equal to 1 centimeter. Convert that into meters, 0.01 meter it will become. Initial velocity u is equal to 0. You have to find out how long or what is the time taken for Mahendra to move 1 centimeter towards Virat. So we have to find out t over here. Now S is equal to ut plus half at square. S is equal to how much? 0.01 is equal to u is 0 into t plus half into a is how much? 5.34 into 10 to the power of minus 9 into t square. Now 0 into t is 0, so 0.01 is equal to half into 5.34 into 10 to the power of minus 9 into t square. We have to find out t. So shift all this number on this side, you will get 0.01 into 2 upon 5.34 into 10 to the power of minus 9, that's equal to t square. So t square is equal to, when you multiply this, you will get 0.02. Take the 10 to the power of minus 9 on the top, it will become plus 9 upon 5.34. Now when you divide this 0.02 by 5.34, you will get 0.003745 into 10 to the power of 9 is equal to t square. Now shift the decimal. You have studied before in your younger standard, the number before the decimal should be between 1 to 10, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So shift the decimal over here. So you'll get what? T square is equal to 3.745 into 10 to the power. Now since you have shifted the decimal, 3 numbers over here, 1, 2, 3, so it will reduce by 3. So 9 minus 3 is how much? 6. When you remove the square of this number, 3.745 into 10 to the power of 6, you will get 1.936 into 10 to the power of 6 will become 10 to the power of 3 seconds. So that's the value of t. Now this is the earth and the water surrounding the earth, the water on the earth, and this is the moon. The level of seawater along the seashore increases and decreases twice a day at regular interval. Sometimes the water level, if you have gone at the seashore, you must have seen sometimes the water level comes very near to the shore and sometimes it goes very far away from the shore. So the level of seawater, when it increases, it is known as high tide, and when it decreases, it is known as low tide. Now why does this level of water keeps on changing? It is because of the gravitational force exerted by the moon on the earth. So because of the gravitational force exerted by the moon, the level of the water increases and decreases. When it increases, it is high tide. When it decreases, it is low tide. Now when it is high tide, the water which is nearer to the moon or closest to the moon gets pulled towards the moon. The moon pulls the water towards it, and over here high tide occurs. And at two places 90 degree to the high tide. That is, if this is a high tide, at 90 degree low tide occurs. 90 degree to the high tide, low tide occurs, and over here also at 90 degree low tide occurs. So at low tide occurs at two places at 90 degree with respect to the high tide. Now we know that the earth attracts every object on the earth because of the gravitational force of attraction. If we throw a stone vertically upward, because of the initial force it goes upward, but as it goes upward the speed goes on decreasing. Why it goes on decreasing? Because of the gravitational force of attraction of the earth, which is pulling it towards downward, that is towards itself. At a particular point it comes and stop over here, but because of the gravitational pull of the earth, which is still there, which is continuously pulling it downward, it will start falling downward. तो अर्थ का ग्रेविटेशनल फोर्स की वजह से जो स्टोन है वो ऊपर जाते जाते उसका स्पीड कम होते जाता है और एक पर्टिकुलर पॉइंट में आके स्टॉप होता है, मगर वो स्टॉप होके उधर रुकता नहीं है. इट स्टार्ट्स फॉलिंग डाउनवर्ड. वाई? बिकॉज ऑफ द फोर्स ऑफ अट्रैक्शन. द ग्रेविटेशनल फोर्स ऑफ अट्रैक्शन इज ऑलवेज टुवर्ड्स द सेंटर ऑफ द अर्थ. वाई? बिकॉज द मास ऑफ द अर्थ इज टुवर्ड्स द सेंटर. द एप्पल and the earth both exert force of attraction between each other, but the earth doesn't come and fall on the apple. Why? Because the mass of the earth is very big compared to that of the mass of the apple. Therefore acceleration due to gravity of the earth is also very small. Acceleration due to gravity of the earth is very small compared to that of the acceleration due to gravity of the apple. Now the moon, which is revolving around the earth, and the artificial satellite which is revolving around the earth, they don't come and fall down on the earth like the apple. Why they don't fall down on the earth? Because they are moving with velocity along their orbit. Because of their velocity along their orbit, the moon and the artificial satellite don't come and fall on the earth. But if this velocity wouldn't have been there, then the moon and the artificial satellite both would have fallen down on the earth.